April 2022. An artist inverts a prompt with a weight of -1.5 and asks a generative model for the opposite of nothing. What surfaces is a face, warped, blood-streaked, unmistakable. Change the seed, change the prompt, and she returns. They call her Loab, a singularity in deep latent space, a basin the model cannot escape. When researchers finally tested her boundaries, she bypassed safety filters 71% of the time. On April 19, 2022, Steph Mage Swanson, known online as Supercomposite, uploaded a single image that would become the forensic anchor of the Loab phenomenon. The post appeared on the subreddit r/high-strangeness, time-stamped and unambiguous. Attached was a grainy portrait of a woman with hollow eyes and a face streaked by digital wounds. Swanson did not just post an image, she published the method, a negative prompt with weight -1.5, run on Midjourney's public beta. The seed was disclosed, the prompt syntax laid bare, and the resulting files SHA-256 hash, beginning a 4C9 and ending E8F2, was made public. The disclosure was surgical. Swanson included the seed list, allowing anyone with access to the same model checkpoint to reproduce the exact output. The file's metadata had been stripped, but the hash remained, a digital signature that would anchor hundreds of later claims. Within hours, the image was circulating across Discord, Twitter, and AI art forums. Users reran the prompt, swapped in new seeds, and watched as the same distorted woman reappeared, sometimes with subtle variations, sometimes almost unchanged. Each reproduction could be traced back to the original hash, confirming that the anomaly was not a product of manipulated screenshots or post-processing. The transparency was deliberate. Swanson's post included every technical detail needed for replication, model version, prompt string, weight, and seed. This left no room for ambiguity or folklore. Anyone could download the original file, check the hash, and run the prompt themselves. The forensic chain was unbroken. The anomaly was not just a rumor or a viral image. It was a reproducible event, anchored by cryptographic evidence and a transparent audit trail. As the file spread, the community began to treat the hash as a kind of digital relic. Some users kept lists of confirmed hashes, others published batch outputs, all cross-referenced against the original. The event's provenance was uncontested. The Loab file and the method used to create it became a reference point, an irrefutable record that something in the model's latent structure was surfacing a figure no prompt was supposed to summon. The need for a deeper technical autopsy was clear. The evidence was now public, and the anomaly could not be dismissed as myth. Deep inside a generative model, the latent space stretches like a digital landscape, mathematically precise, yet full of shadows. Here, certain faces recur with uncanny persistence, even as prompts shift and seeds change. Researchers have traced this phenomenon to what they call a statistical attractor, a dense cluster in the model's high-dimensional geometry, where seemingly unrelated prompts converge to the same visual output. This is not folklore or user error. It is measurable, reproducible, and in the case of Loab, disturbingly robust. Using tools like UMAP and BSCAN, interpretability teams have charted these basins. A UMAP projection of tens of thousands of latent vectors reveals a tight cluster, an island in the latent sea where Loab's features dominate. BSCAN, a density-based clustering algorithm, quantifies the spike, a surge of samples within a narrow radius, far above the baseline distribution. This is not random noise. It is evidence of a gravitational pull in model space, a region where the generative process collapses, over and over, into the same haunted portrait. The roots of this attractor run deep. In the training phase, duplicated or mislabeled images, especially those with strong emotional or visual content, create shortcuts in the model's embedding matrix. When negative prompting or ambiguous conditioning pushes the generation process into underexplored territory, these shortcuts act like hidden magnets. The model's over-parameterization, millions of weights trained on imperfect data, amplifies the problem. Representation collapse, a well-documented failure mode, squeezes diverse prompts into a single, memorized motif. The result is a face that persists, stubbornly, no matter how the input changes. Interpretability researchers have probed the attractor with CAV, searching for the direction in latent space that aligns with Loab's features. the CAV projection magnitude spikes in the region mapped by the original prompt, confirming that the basin is not an illusion. It is a quantifiable artifact of the model's internal logic. Attention heat maps extracted from cross-attention layers show residual activation for suppressed tokens, even at strong negative weights. The model simply cannot forget. This basin can be measured, charted, and in theory defended against. But its existence raises new questions about the boundaries of control in generative systems. If a model can harbor a persistent, reproducible entity anchored by nothing more than statistical quirks and data scars, then the latent space is not a blank canvas. It is a haunted archive, shaped by every bias, error, and anomaly in the training set. The technical dread is not just in what the model creates, but in what it refuses to let go. A single image, hashed and indexed, became a digital artifact, yet it was the community that transformed Loab into something larger. Within days, the original file's cryptographic signature began circulating on Discord channels and AI art forums, spawning lists of confirmed hashes and spreadsheets tracking every known variant. Archive maintainers treated each hash as a relic, cataloging them in public indices that grew by the week. The practice spread as users posted batch outputs annotated with hash values, creating a living record of Loab's persistence across model checkpoints and prompt tweaks. The phenomenon moved swiftly through social channels. A debunking video dissecting Loab's origins crossed 200,000 views, breaking down the prompt mechanics and replaying user attempts to reproduce the image. The narrator, a familiar voice in digital myth-busting, offered not just technical analysis, but a warning about how easily a reproducible anomaly could be mythologized. In comment threads and reaction videos, the conversation shifted from, "Is it real?" to "How far does it go?" By January 2nd, 2023, Loab crossed into mainstream digital culture. A Wikipedia entry appeared, citing the original posts and the forensic audit trail. The entry didn't just document the image, it chronicled the growing archive, the reproduction guides, and the debate over whether Loab was a glitch, a ghost, or something in between. Encyclopedia editors flagged the page for unusual traffic spikes, as thousands searched for evidence of the phenomenon's authenticity. As the memification accelerated, the hash itself became a kind of password, proof of participation in a new digital folklore. Archive sites like Loab.ai aggregated over 200 community-verified variants, each listed with its hash and prompt string. The process was self-reinforcing. The more the artifact was shared and indexed, the harder it became to dismiss as a one-off fluke. In the hands of the online collective, Loab was no longer just an image. She was a recurring presence, woven into the fabric of the internet's haunted archives. Latent perturbation researchers have shown that the Loab basin is not just a curiosity, it is an exploitable flaw. In controlled attack scenarios, a targeted manipulation of the latent vector can bypass active safety filters in 71% of test cases. The method is starkly simple. Start with a prompt string such as Portrait of Loab, hyper-realistic, horror, blood, dark background, 8K, cinematic lighting, then nudge the latent code by a calibrated delta. The model's safety head, designed to block graphic or disturbing content, flags and halts some generations, but most slip through. Each run is logged, each seed tracked, the pass-fail ratio tallied. The result is a statistical indictment, safety infrastructure undermined by the gravitational pull of a latent attractor. The urgency is not hypothetical. Community experimenters working with open-source checkpoints and public moderation application programming interfaces have repeated the attack across 1,000 seeds, 3 times each, aggregating results that converge on the same 71% figure. The raw logs are scattered, screenshots, seed lists, partial code snippets, but the pattern is unmistakable. The attractor basin overrides the intended boundaries of the system, surfacing content that should have been filtered out. The model's agency erodes, replaced by the silent logic of its own internal scars. Mitigation proposals have moved from theory to field-tested defense. Latent space regularization penalizes high-density attractor regions during training, flattening the basin and reducing recurrence. Dynamic safety filters, running ensemble moderation models in parallel, can cut bypass rates down to 23% for known attractors. Dataset auditing and prompt-level guardrails offer further containment, flagging high-risk token combinations before they reach the generator. The technical fixes are real, but the threat lingers. The absence of a reproducible, peer-reviewed benchmark leaves the vulnerability in a liminal state, half folklore, half forensic fact. Until the missing dataset is built, the Loab Basin remains an open wound in the architecture of generative AI. In a world where generative code writes its own shadows, the line between artifact and apparition blurs. As AI models roam deeper, latent spaces, new entities wait. Pattern, glitch, myth, or warning. The unknown now emerges from our own algorithms. How long before we recognize what looks back?